afternoon or evening or morning or whatever time it happens to be wherever you live. Today in the Combo Classroom, I wanted to do a little live stream to check up on a topic that's a cool, simple, open question. And by simple, I don't mean simple to solve, I mean simple to describe. And this open question, related to what are called diagonal Ramsey numbers, has some cool updates that occurred. I originally talked about these numbers in a main episode on my combo class channel about a year and a half ago or so. And since then, there have been some new upgrades, particularly last September. A cool thing was proven about a particular mysterious number, R55. And in this live stream, I will refresh, or for the first time, fresh, your memory on what it means to be a Ramsey number and what's up with this open question. But you may want to, if you're watching this in the future, you can watch the live stream version right now or the main episode I've made about that portion. And after I refresh or renew or teach some of you for the first time what it means to be a Ramsey number and what R55 is, then we'll jump into some new upgrades. And then we will get on to other topics, such as chatting about random upgrades in my life and classroom and so on. And also, I have a cool vegetable we might try. Check this out. Got a Romanesque broccoli, or broccoli romanesco, also known as cauliflower romanesco. It's not technically broccoli or cauliflower, but it's in their family. So that's a really neat vegetable. This is a kind of cool looking fruit I was eating the other day too. This dragon fruit. Pretty wacky looking. Maybe we'll do a taste test of this fella later. But for now, let's jump into what it means to be a Ramsey number. This is related to graph theory, and not graphs like coordinate plane graphs, but in graph theory, the crucial thing you need to know is that we have different points, and they may or may not be connected in different ways. And where I draw the points, like if this next one's here or over here, isn't what matters, but the way they're connected is what matters. And there are different sorts of graphs we could have here, and the type that we're doing today could be described in two equivalent ways. One of them is we have some set of points, and we're wondering some of them are connected and some of them are not connected in each pair. Or we could say we have two colors that the non-connected are a color. So basically, this could be seen as drawing the invisible connections that are the non-connections. And either way, what we're looking for is arrangements within the connections or within the non-connections. In particular, in this part of Ramsey theory, it relates to wondering if this sort of graph, or a larger sort, contain, and wait, is this in bad glare? Okay, it's in bad glare. Maybe this will help. Okay, it's unsturdy, but it helps. So we're wondering if graphs like this contain smaller graphs anywhere in them. For example, let's say I'm wondering if this contains 3 points that are all, we can say brown is connected and blue is non-connected, let's say, or 3 points that are all like that. Are or aren't, whichever way we assign the colors doesn't matter. And so here, this graph we can see does have the blue one. It has, a triangle of 3 blue ones that are all connected. And if I had a different graph, maybe if this was also non-connected, now it's harder to find a triangle like that. We can't find 3, oh no, we can still. Those 3 are all connected. Let's say this one was brown. Well, then I end up with one where we have a triangle of non-connected. Well, it turns out that I can make a graph of 5 points that do not contain either of these. And it's basically having one of them, the connections or non-connections, be like a pentagonal-ish shape if we unravel it, and one of them being a star-like shape. This arrangement does not have any three that are all connected or that none of them are connected. Same with the flipped version of this if I swap the colors. However, if I have 6 dots, I am guaranteed one of these. And it's an inclusive OR, like I'm going to get one of these or one of these, but the type of OR that means and or. It could be both, but it's saying at least one of these will always appear in a graph with 6 dots that has this sort of coloration, either seeing connections and non-connections between each pair or coloring the non-connections. And because the minimum amount of dots that guarantees that is 6, that guaranteed we'd have at least 3 of one of these types, we say that R33 equals 6. That is what the Ramsey number is categorizing, the minimum size of bigger graph that contains a certain amount connected or a certain amount not connected. If I had R23, for example, which is equivalent to R32, those would mean that I'm looking for 3 connected or just 2 not connected, or vice versa. These ones are known as the diagonal Ramsey numbers because if you imagined a table of all the Ramsey numbers you could have with these 2 inputs, when the inputs are the same for those, it would be diagonal down your table. And the diagonal Ramsey numbers are the main one we're going to be looking at today because although it's easy to prove this, and we'll even look at a proof for it in a bit, it gets hard to prove this about larger graphs, and it also becomes hard to check all of them. It's the type of question that if you had infinite computer power, you could check with brute force manually. But we don't have infinite computing power, and humans have to work alongside robots to come up with a new proof that basically establishes a set of graphs that they prove. If we know something about these, we know something about all of them. And then the computer has to check all of those. In many cases like this, that's how new results get proven. We wait for a human to come up with some new advancement, and that puts us in range of something the robot can test. Now, also, as we get higher up, it's going to be harder to try and make each new one work if we don't have a generalized formula, but computers get better over the years. So kind of like the hunt for large primes, it's sort of hard to predict if this will speed up or slow down our rate of knowing new details about these. You know, we're getting faster with computing abilities and with proof techniques, but we're getting to terrains where we get absurdly large amounts of ways things could be connected. Like, for example, R44, I think is 18. Let me double check this real quick. R44 is 18. And what this says is this has been proven, but it's not as easy to prove as this one. This says that any party of size at least 18, and I'll explain what I mean by party in a minute. That's an analogy for these. Any graph with that many dots with at least 18 must either have 4 all disconnected or all connected. So now it's like this shape we're looking for. You see, like we need 4 of them. Doesn't matter here what color I'm drawing the points. I should actually keep it standardized and draw the points brown like I have been. But that doesn't matter. The points are colorless, so the connections are colored. So we're looking for that or that. And we're guaranteed one of those in 18 dots, but not in 17 dots. So that's why it's 18. Now, when we look at the first few of these, we have R11 equals 1. R22 equal, oh no wait, is R21 2? Let me double check these as I go forward. Wait, I have these here somewhere. Yeah. So R11 is 1. R22 is, no wait, sorry. R11 is 1. This is where I got confused. R22 is 2. And these you can figure out on your own what those would mean. They're like shrunken versions of these. It doesn't take a very big graph to require 2 connected or 2 disconnected. It requires 2 dots, but requires 6 dots for that, then 18. When you look at these, you may wonder, hey, look, that one's twice the last. That one's 3 times the last. That one's 3 times the last. But we know that R55 is within a range where it's impossible for it to be an integer multiple of 18. So that pattern breaks. It's not. Each one's not a whole number times the last. Because we know that R55 is between 43 and this would say 48, and it does in the episode I made about this a year and a half ago, but it's since been proven it's 46. And that is one of the things we'll be covering today. The new proof that came out in September, which is a mix, like I was describing, of human work and computer work. And, that shows that R55 isn't more than 46. And here, let's just get extra close on this for 1 second to make that oh no, I'm dropping my broccoli thing. Oh, gotta be careful with this. So my fractal approximation vegetable, and my chair sinks in the mud so much. It's been raining like crazy around here, so my chair is sinking at this weird angle in the mud. I need less spiky chairs. Anyway, here we can see a little better. This is how the pattern starts going up, but then, wait a minute, 43 to 46, which isn't an integer multiple of the last. Mathematicians have looked long and hard for a generalized formula, but it's hard to know if there even is a generalized formula for those. Not everything has an easy closed form expression, so it depends what you mean by formula. But there could be some really cool thing we find out, and we'll look at some conjectured ones in this stream that are something we can just plug in a number to, and it'll tell us that diagonal Ramsey number. But we're nowhere close to that. We have upper and lower bounds proven for just RNN, but it's a really wide range, the upper and lower bounds. The general one doesn't help us with R55, for example. We've proven more about this than the generalized bounds that we're able to make. We'll look at those too, but those have been ticking along a bit slower than progress on specific ones of these. Actually, no, just slower, I'm thinking, just because it went extra fast since I made the episode. They came out with this upgrade. But I guess around the time I made the episode, I think a little before, maybe a little after, there was another update on the general formula. We'll look at that too in a minute. Now, first, I want to share a quote from a great mathematician, Paul Erdős, or the version of the quote I found here is actually someone else describing something he said to them. But in any case, here's a quote from the great mathematician, Paul Erdős. This is by Joel Spencer, describing something Erdős said. Erdős asks us to imagine an alien force vastly more powerful than us, landing on Earth and demanding the value of R55, or they will destroy our planet. In that case, he claims we should marshal all our computers and all our mathematicians and attempt to find the value. Meaning that this is within our range. If we tried really, really hard, it could be possible to prove which one it is. But he says, but suppose instead they ask for R66. In that case, he believes we should attempt to destroy the aliens. Meaning that if they ask for R66, we have a painfully small chance of calculating that within a reasonable amount of time, or coming up with a proof for what it is. Even if we need to guess what it is, we're kind of in trouble for R66, because R66 is known to be between 102 and 160. So we have a low chance with a guess there. If we are allowed to guess, though, we have recently gone from a 1 in 6 chance of being destroyed to a 1 in 4 chance in the R55 circumstance. So here I'm going to, this chair. Here I'm going to show a table on Wikipedia. Don't quote this table because it is just on Wikipedia and I don't see citations for all of them here. So don't quote this for sure, but this is approximately, at least, if not exactly, what is known about particular Ramsey numbers. And it's a whole table of Rn, N, or Nm. So the diagonals are sort of the ones we were looking at. And they actually only have half the table filled in because the other half's symmetrical. Like RNM equals RMN. Now, let's also, as I pull this, oh, squirrel. Is that a squirrel? Whoa, it's squirrel. I missed the squirrel. I don't know if I got it on the camera, but it knocked something over. I heard something scurried over there and knocked over a clock. I'll put that back later. Anyway, let's get open the screen capture. And like I said, don't quote this because this is just Wikipedia, but it is, I guess it is mostly quoting this OEIS sequence. So I do trust that to a degree as long as they transferred it to here properly. This is about what we know. 1, 2, 6, 18, 43 to 46. And these are things that are proven. The greens are proven. Yellows are just ranges we know for different ones. Kind of cool to see the pattern. These are all 1. This one goes up like the natural numbers. This one, nothing has been proven about a general formula. We can see once we get further. And a lot of these have pretty wide ranges. As we get up here, look how wide that range is. If they ask for R1010, the aliens were screwed. So let's now also, before I move any further, I want to explain an analogy for this to help it sink in better and to show how it relates to life circumstances. Let's say there's a party you have, or a party that exists, and there are N people at the party. Well, not the same N I've been using here. So let's just say there's some amount of people at the party, which is the amount of dots on our graph. Well, if we want to know some subset of people there. Oh, the squirrel's back. Where'd it go? Oh, there it is. Oh, that's a good squirrel. I hope that was visible. Anyway, if you're at a party, the amount of dots is the amount of people. You're wondering if there's any subset of people there that either all, we're going to pick any random binary thing. That everyone there either gave each other a handshake or didn't at the party. Well, this is saying that a party of 18 is the smallest size guaranteed, regardless of how the handshakes going down, that you will have a subset of at least 4 that all shook each other's hand, and or a subset of at least 4 that all didn't shake each other's hand. So that's an example of how this could be applied to many life scenarios. And the more general concept, which will be explored in various videos of mine, is known as Ramsey theory, although this is a particular little subset of it, where there's a particular Ramsey's theorem, which states that this was it being proven by this guy Ramsey, that there is always some finite answer. That for RNN or RNM2 does have some finite answer in every case. So also looking at our comments, thank you to everyone joining me. And someone asked if it's a premiere or am I real? I am real. This is when I do a live stream. I have never yet at least done one that's just premiering pre-recorded content, because if I'm going to do that, why have it be a live stream? So this one is real time. And someone says blink 4 times if I cannot detect it. The blink test isn't going to work really well. That's not a good secret code, because how fast do you have to blink between? Does that count as 2? Is that 2 blinks or what? Because I'm not keeping track of my blinks to make a code. I have a lot of secret codes in my content, but it's not the blinking, unless I'm just trying to mislead you with that. Maybe you have to rewatch all of my episodes and track some binary pattern of blinks and non-blinks in some way, and that actually is the content of each episode, whatever the binary code there translates to. That is probably not the actual codes I put in my videos. I have hidden things in videos before. Anyway, with Ramsey numbers, there are plenty of cool things that we can go into. One of the main ones I wanted to go into today was the paper that came out last September that showed that instead of an upper range of 48, they were down to 46. Let's also first, real quick, look at another paper. This one is the general case for diagonal Ramsey numbers. This is a paper that came out in March of 2023, still quite recent. And we can see, this is an exponential, probably a pun on the exponent, improvement for diagonal Ramsey numbers. It shows that R of k, R being, this is like the Ramsey number where they're the same, like 5, 5 or 6, 6. They're just simplifying that and saying R of k here means the diagonal Ramsey number. And here they say it's less than or equal to 4 minus some small constant. They're not using this to mean infinitely small. It is actually a constant they have proven. It is 1 over 100 something. I think it's 1 over 128 or something, what this E is. But what this shows is that R of k is definitely less than 4 to the k. So if I want to know what's R of 10, 10, that can't be more than 4 to the 10th power. Can't even be equal to it because of this minus a little bit. That is not the best bound we have on many of them. So that doesn't really help us, but separately it's a cool quest to see if we could get a generalized upper bound, because we're not calculating things about like R 50/50, but the general bound tells us something about that. And here's a little look at this paper. It's like, is it highlighting all the numbers here? I guess, oh, maybe so you can jump to them. That's cool. So here we can see how they proved this is using a lot of mathematics. And here we have some algorithms doing things as well. And it's sort of fun, even if you don't fully go into what this proof's saying. We'll look a little deeper at the next one I'm going to show. Sort of cool to see just how they phrase things. Like, you often think that in a proof, they have to use really technical language. But they don't have to. They can call it whatever they want. And some of the ways they describe things are sometimes fun. Graph theory is one of the ones that has a bunch of wacky nicknames. This has a little less of that, but still, yeah, like zigzag lemma. You got some cool names for stuff. The book algorithm. This is the book algorithm. And it has the big blue step. I see the red step. I like how they describe some of this stuff while still doing concrete mathematics. These are proofs that have been double-checked by other mathematicians and are widely considered to be verified. A lot of mathematics going on. Now this one, I'm just going to skim through. This took a lot for them to prove that new bound. Now this one came out almost 2 years ago. But there's one that came out just like 4.5 months ago that's just about R55. And that I have here. This was the one proven recently by Vigliak, Angeltveit, and Brendan McKay. And they did use computations, but they make sure to note all the computations were independently replicated. Another mathematician used a different sort of software to check the computations. And it does use a they describe sort of what I was saying. It uses a combination of linear programming and checking a large number of cases by computer. The linear programming is stuff figured out by humans. This is figured out by machine. And I remember hearing something about it was many years of computation power to get this result, because they narrowed it down to certain cases that would prove the full thing. And those certain cases were less than the absurdly large number of graphs that could exist for 43 through 46 dots in general. But they narrowed it down. Then the computer still had to do a lot of checking. So, and computers, because they wanted to make sure on another check of it. So here we have that's describing sort of that a little clearer. They had 352,366 graphs, like different arrangements here, that catalogs one of the things they were checking. Oh, the squirrel's back. Oh, I went over the thing already, I guess. Never mind. Anyway, here we have some things about another one of the names I thought was fun is where here they use this thing called like the gluing strategy or something. What exactly do they call it here? The gluing computations. So yeah, they're gluing computations. Describe what's happening. I love the language of math. Sometimes. Some names, like imaginary numbers, suck. But I like that there's a lot of ways that describe things in sort of analogy-like ways. So, overall, what they have proven here in this paper is we knew it was from 43. It actually was 49 not that long ago. 49 then was bumped down to 48 in another paper. But this paper got it down to 46. Now, like I noted, it's hard to know due to the mix of the growth of the amounts of graphs to check and the growth of computer abilities and mathematical abilities. It's hard to know whether this will continue happening at a good rate, proving more about the bound, which for R55, we only need to do a few more times. If we get this type of result just a couple more times, we're going to know what R55 is, because it's between 43 and 46. And R66, we might have a lot more times that we have to narrow the bound. There could be 10 different papers before we know R66 that slowly bump it inward. Now, some mathematicians think this is the type of thing that the big ones are just beyond mathematics currently. However, I like to be optimistic, and I think that it could be not a crazy amount of years before we know R55, maybe even R66, but maybe that one's being overly optimistic. Now, one thing I do want to show in a minute is it's very interesting to look at sequences of numbers that could be an equation that could predict every next one for the diagonal Ramsey numbers. And we can do that by going on like the OEIS, Online Encyclopedia of Integer Sequences, and looking like, okay, what sequences go 1, 2, 6, 18, 43? Which ones go 1, 2, 6, 18, 44? And this eliminated a lot of possibilities with the new result, because now we know it's not a pattern that would lead to 1, 2, 6, 18, 47, or 48. So there are now limited ranges. It limited down the amount of hypotheses we need to wonder about of potential formulas that could describe them, although we don't know that there is one of those in a simple closed form expression or not. It's nice to think that there is. It has to be somehow something, whether it's using the ceiling or floor of a number or just already doing this. It has to somehow, generate this chair. It's ridiculous. It just sinks into the mud like crazy. I need a less pointy chair back here after it rains. The classroom was straight up flooded yesterday. It's drained pretty well, but it was a lake on that part of the yard and the front, one of the ends of the classroom. Maybe I'll show some footage of that later. I also went on a very rainy walk because my neighborhood gets flooded, and I've gotten a new fun hobby, which is taking title cards or props and filming them in places like rain gutters sliding down and stuff. Don't worry, I never litter. I make sure they don't get left behind or go into a drain or anything. But when it was raining and these storm drains were going really fast of a bunch of water tunneling down, I was putting title cards in it and then racing alongside it with the camera so that the thing's still in the shot, but you can see it sort of like flying down the water. And some of those shots may be in the next main episode. The next main combo class episode will be out in about a week, and it will relate to logical paradoxes and logic puzzles. So if you are familiar with these concepts, I won't go into it in detail, but it relates to extensions to the liar paradox and also ways of symbolizing this in a type of puzzle called knight and knave puzzles. It is somewhat inspired by, as I'll mention in the episode, the author Raymond Smullyan, who is one of my favorite mathematical writers. Now, thank you to everyone who's joining and hanging out to read these things. I think we may go through this proof in more detail later to see how we could decode it more. But for now, I think one of the next things I'm going to do is pull open the OEIS, like I mentioned, Online Encyclopedia of Integer Sequences, and look at some hypothetical sequences that maybe could theoretically describe these, because all of the terms in the sequence land in the known range for the unknown ones. So we're going to look up 1, 2, 6, 18, and then the next one, there's 4 possibilities. So I'm going to create a different tab for each of these. One that goes to 43. Actually, no, wait, 43 already dead ends. 43 does not match a sequence. There aren't any that, this matches after removing the first term, but not close enough here. So there aren't any sequences on the OEIS that catalogs the most important, well-known fundamental sequences. There aren't any that hypothesize it's 43. I would guess it's probably not 43. It seems weird to go from all these divisible numbers to 43, but who knows? What about 44? Here we can see this one goes negative on half of them, but maybe it's somehow the absolute value of one of these. Except for the fact that after 44 we get to negative 56, that the absolute value wouldn't be big enough to be in the known range of R66. And that's the only one for that. But 45 and 46 I think had some more. 45, we do have some. This one is the one that mentions, even, it is a conjecture that maybe this is the equation for diagonal Ramsey numbers. And let's write it out because it's kind of hard to see what they're writing here. It's, let's see. No, it's okay. You can see it in this form. But I don't know if I believe this is the equation for them, but it could be, because we go up into all of the ranges. This would be weird though. It's known this is 102 to 160. This would put this really low in its possible range. The lowest possibility for this. Possible though. Here we have another one, a more complicated looking formula that does seem to land in the ranges. Is 252 in the next one? Yeah, so this one theoretically could, for all we know, be an equation for the diagonal Ramsey numbers. Similarly, if we go to 46, this shows some other possibilities. The number of permutations satisfying this. Or this about acrylic orientations of a particular graph. However, this one doesn't have it at the beginning, so this probably isn't it, because it's buried in the middle here and then it goes back to 1. So not this one. Here, it is at the, oh no, I was going to say possible, but not. That's a little under the range. That one we know is 102 to 160. Here's another possible one. That'd be fun if this one's 1, 2, 3, 4. Oh, whoa, this one's super 5-y. Anyway, here's another one. One more possibility. This one refers to another sequence numbers that this equals 1. That's not in the range, though, so not that one. Some of these are possibilities, but with this new proof, we have eliminated some. It's not this. This is not it, because we now know 46 or less. This one was also, this was also something that could have been the case till last September. Not anymore. So those are some fun notes about how we could, if we see a pattern go to something like the OEIS and look at potential patterns, suspects that could possibly describe it. And somebody asked, has this been tested at real parties, asking the guests who they know and don't know? I don't know if it has. That could be a fun video sometime. If I ever return to Ramsey numbers, maybe I'll try and do a real life party scene where I figure out some binary trait that each pair would have on or off. And for like along the lines of are they friends or not, but in a slightly clearer mathematical way. Like I said, did they give each other a handshake? And we just have to judge each semi-handshake as either yes or no. So you could test it at real parties because mathematically it's proven. So that would be a fun, not really experiment to prove anything new about it, because too many parties to throw, like too many ways that 43 people can have these connections or not to test all those with humans on Earth. Even a robot can't do it right now. But you could verify some of these or sort of show them. Like, it would actually be good for a math teacher with a class of students to show them, come up with some trait that everyone has to be able to figure out if that pair is or isn't connected in that way. And then when you map it out, like a class of 30 students would have to have 4-4. Would have to have either 4 that all had the binary connection or 4 that none of them did. So if you're a math teacher, maybe do that with your students. And I need to run inside and get some water briefly, but hold on. I sometimes just vacate the camera for a minute and hope you folks see a squirrel or something. This time, I'm just going to go directly to some footage that you guys can actually watch. And what I'm going to do here is one of the recent bonus videos I put out on Patreon was about some cool birds that I've seen big flocks of recently. And there are cool bonus videos if you sign up on Patreon or on the YouTube memberships here. And for example, cooking these in different ways, or the new one about encountering birds. I'm going to show that the beginning, just the very beginning, shown for free for here. And don't worry if you can't support. I make sure my best content is free for everybody. But I like to have some bonus stuff to give people who do support financially. And I'm going to show the very beginning of that. It's going to be muted, I guess. But you'll get to watch the very beginning of this bird thing. And it actually starts with me showing that the classroom was really flooded. But as I run inside for 1 second, then we'll come back to Ramsey numbers. You can watch the very beginning of some. Imagine what I'm saying is, and this is a type of bird called this that I saw, and this is a type of bird called this that I saw. Okay, I will be back shortly. This is first just showing how the classroom's flooded, by the way. Or how it was. This was yesterday. Okay, what is up, folks? How are you doing? Hopefully you enjoyed a little bit of that. There is a bit more, and there's a funny little story in that if you are signed up on my Patreon or YouTube memberships. But I'll save that or see if it works in a future episode. I also someday may compile the bonus secret stuff I do and release... Oh, squirrel. And release it here in some form. I don't know if you saw it. It's gone. But we'll see. Maybe sometime I'll post all of the bonus stuff from previous years' Patreon and memberships for free. Most of the stuff I like to put out for free because my goal is to educate people and to let people have fun while doing it. And so whenever I come up with something extra special that I film that does make it into my episodes, the next ones will be quite cool as well. And now jumping back just a little more into the Ramsey numbers, why don't we look at, this is just going to be the Wikipedia description of it, but we'll follow along mentally. I'll explain through it. And it's a similar, basically the same type of proof, that is the easiest type of proof to do for this, that shows that R33 is 6. And what we're going to do here is look at how you can use clever logic to prove some things. And theoretically, without any computers being involved, there's a chance that some mathematician will come up with some really clever way to just prove what R55 is. Now, we can prove that R33 is more than 5 just by coming up with a graph that doesn't fulfill it, that has 5 dots. This does not fulfill what R33 needs. It doesn't have a triangle of dots that are either all connected or none are connected. And so we know that it's more than 5. But how do we prove it's 6? How do we prove every way that we could connect 6 dots, which already, it's not as much as 43 dots, but already a lot of ways to connect them, that every single way either contains a fully connected triangle or a fully unconnected triangle. And remember, it's the inclusive type of or, so you can have both also. So let's walk through a version of the proof that shows R33 is 6. So here we have a graph we're imagining. Our graph has 6 dots, and we don't know how they're connected. Let's pick a corner. And they're saying red and blue. So red versus blue is like connected versus disconnected. It doesn't matter which is which, but all of the connections in their one are red or blue. And we're looking to prove that there's definitely a triangle that's all red or definitely a triangle that's all blue, at least one of those. So we pick a corner. There are 5 other corners that could connect to that. So at least 3 of the ones connected to it by what's called the pigeonhole principle. That's like, if you have 7 pigeons and 6 cages, you're going to need to put more than 1 pigeon per cage. Here, by that sort of principle, we can think that, okay, if I'm connected to 5 things, no matter how that is, there's either at least 3 of one color or at least 3 of the other color, meaning like at least 3 connected versus at least 3 disconnected if we're talking about handshakes or something. So, but here just imagine the not handshakers are colored a different color. So without loss of generality, we can assume 3 of the edges are blue because we can make a flipped version of this proof with red. You could just test it from blue and then test it from red to fully know, but the red proof is a flip of the blue proof. So we can basically assume, since it's all equivalent to flip it, that the one that has more connected, the color that more of the 5 are connected to that original vertex, is the blue one. And here, if any of the edges, now here we have to look at their image to make it extra clear. V is the vertex that we're imagining could be connected to 5 things. Now we're going to say that it's connected to these 3, Z, Y, and X, because it doesn't matter. We're allowed to slide around the dots and it ends up being equivalent. And then we're going to say if any of these triangles here are connected, if any of these three between the three ones that we said are going in the dominant color to V, if any of those are that same dominant color, that would make a triangle. There, there, or there. So we can note that if not, so yeah, imagine any of these are blue. Then we have a triangle there, or this triangle. But if they're not blue, then all three of these are red, or the other color, and they form their own triangle. So just to do that one more time, there's one corner that's connected to 5. It has some dominant color that connects it to 3 or more of the others. If any of those 3 are connected among themselves, that creates a triangle from that original vertex. And if none of them are, they create their own triangle, because none means they're all the other color. They note some other possible ways you could prove it as well. This proof by double counting that they say right here. Now we can also have Ramsey numbers with multiple colors. R333, if we had 3 ways that each pair could be connected. They either high-fived, handshaked, or neither. We'll say none did both. Then we can say that any party of 17 people must have 3 that are all one of those 3 possible connections. And it's known that 334 is 30. They even use these bigger ones sometimes within the proofs to show things about other ones. And these are some cool graphs that emerge as we go through this. And here's a little proof of what's called Ramsey's theorem in general that shows that there is always some finite answer for any R something. And that's for 2 colors, then case of more colors. And the Ramsey numbers are the special numbers that sort of emerge as these minimums. And we don't know that much about these ones. So that's all pretty neat. If you do want to see more about it, make sure that you've checked out either now or later. You can wait till after the stream, but later at some point, check out on my main combo class channel. I made an episode about Ramsey numbers a while ago. That was... Where is it? Oh, I missed it somewhere there. The Mystery of the Unknown Ramsey Numbers. Also, just a note while we're on here, the last few episodes have been doing well. That is awesome. So make sure you do check out this channel. Everything I put out on here, like on this Demotro channel, I put out a lot of different random stuff, and some of it will interest you more, some of it will interest you less, but all the combo class main episodes are ones that I hope everyone who likes my content in any way watches, that I think contain cool, deep bits of learning and or fun. So that is most of what we'll discuss about Ramsey numbers today. We may discuss some other cool open questions, but the good news is that since last September, if Erdish's hypothetical alien attack occurs with R55, we have upped our chances of survival based on a random guess, if we had to do it right then, from 1 out of 6 to 1 out of 4. So, let me pull open a little couple notes I had here of other things I wanted to discuss in this stream. So, oh yeah, we have the broccoli too. Even though it's sitting right here, the note was what reminded me. So, we're going to do a little taste test of this in a minute. I'm going to show how even raw, they are delicious. I'm just going to take a bite out of this. And cooked, they're pretty good too, but honestly, the more you cook them, it's weird. They go back a level of fractal approximation. Here you have like 4 layers of bumps on bumps, about 4 to 5 layers of that. And it like goes back a layer of fractal approximation where it looks like 1 less amount of bump on each bump or something when you boil it. It's trippy. Not if you bake it, but if you boil it. And then the best way I tried eating it was probably steamed, the part of the boiled one that was out of the boiling water, but steaming. That was good, but honestly, raw was really good. Me and my mom, after I filmed with one of these the first time, we were like, let's just try a couple bites of it. And we ate the whole thing raw. It was a bigger one than this. We were just sitting there snacking on it. It was really good. So we're going to take a bite of this in a moment. But some other things I wanted to share are, so it has been raining like crazy. That will show up in some of the next couple episodes. Hopefully not as much during the main takes I'm filming, because I want some sunshine to film those. But in title cards and things like that, I took advantage of the flooded areas in some different ways, so don't be surprised if you see some title card or like B-roll type shots that are clocks or calendars or things floating through murky areas. It's also fun just to go down to the flooded areas because birds like it. They go there and get worms and stuff. Not on the concrete flooded areas, but out in the dirt flooded areas at the marina. And I also wanted to note about that, kind of random note, but my cat Dandelion, the fluffy one, who many of you are familiar with, I think has developed a new technique to get pets. And he has a lot of good luring techniques where he'll like, he runs in front of you and then flops out with his belly up. If that doesn't work, he'll stretch really long and it looks so cute. It always works. But even if I'm really busy rushing somewhere, it's so hard to resist his lure. And he has a new one, I think. I think he's purposefully, when it rains, going out, because when the cats come in wet, they're good boys and they let me and other family people towel them off. So you can take a towel and dry them off, and they like it. And he, I think, is going out on purpose just to get soaked, coming right back, because he likes getting toweled off. It feels like getting pets. So I swear, he was like getting toweled off, going right back out, coming back. Okay, time for my towel again. Anyway, the rain hopefully will pause a bit, partially because, or hopefully it won't extend that far from this area, because I am going on a little trip this weekend. I'm going to a friend's cabin from about Friday through Monday, so I won't be around to post stuff then. I don't know if there's even Wi-Fi at the cabin, but I will hopefully be filming some cool clips out in nature, possibly even snow. I don't think there's snow right at the cabin, but a short drive away, I think there will be. So maybe we'll get some fun shots in the snow. Leave a comment if you think there's anything particularly interesting or funny I could film in the snow. Anyway, another thing I wanted to mention real quick. I have started actually checking the Combo Class Discord server more, and I'm going to check that at least once a week now whenever I can, because I do want to keep more up to date with like conversations that different combo lords are having and replying to people's messages and stuff. I'm still working on going through all the emails I've gotten from people, but I have started going through the Discord messages that were old, so feel free to find the combo lords on there if you want. I think the link may have been expired for a bit. That was in the descriptions here, but the current link is a good one. So feel free to join some cool discussions on there if you want. I don't normally use Discord, but that one is the combo class one. And also, just to mention one last time real quick, if you do have any possible way of doing it, it really helps to support on the YouTube memberships or Patreon and stuff like that. And thanks a lot to the people who are doing that. Now, as far as my main channel, like I said, it'll be in about a week. There will be another episode, and it's related to logic paradoxes. I've been spending a lot of my combo class time on... Wait, where'd that go? What happened? Oh, okay. A lot of my combo class time on the main channel, the combo class one, and making sure the last couple episodes were coming out pretty quickly and really good. But the next few episodes are going to take a couple weeks between each of them, and during that time, I am going to try and catch up this bonus channel on more things. I have a lot of stuff I filmed and never edited or put out, so I might put out some stuff, some of it maybe even as far back as when I had longer hair. That is some fun content I didn't put out yet for some reason. But I also have a lot of other fun ideas of things to do on this channel. So I'm going to start putting a little more time each week into the bonus content on here as well, such as more shorts and things like that. And let's see, did I have any last notes I wanted to share? I guess that's all I'm going to share at the moment. I kind of want to talk about some really bad things that are happening in America where I live currently, but people often don't like when I get political, so I won't do that today. I'm sure some people are fine with it, but a lot of people just don't want politics on a channel that doesn't normally do that. So I won't go into that today, but not great things are happening in America at the moment. And hopefully things are going okay in all of your individual worlds. Things are okay in my world. I just mean in general for a lot of parts of America. But things are okay in my world at the moment, luckily, and hopefully the same for you folks. Now, there's some other fun things I've been doing recently, but I won't describe all of them because some of them will just show up in backgrounds of bits of different combo class episodes. Like in that bird footage I showed earlier, you may have noticed that there were a lot of shots that had a lot of sky, and that's room to put text or something. I've been liking handwritten title cards a lot recently, but also sometimes it's fun to put the title card stuff as text on a background. At some point, maybe just when I work with other editors, or maybe just when I find the time to do this, I might start putting more time into the editing on this channel, because most of the stuff on this channel is like 1 or 2 takes of just me talking to the camera, whereas the other channel, I put a large amount of time into having different locations and different bits of soundtracks and different cool looking title cards and stuff. So at some point, maybe I'll find a way to expand that more to this channel as well. One thing that will be coming out in the near-ish future of Combo Class is some musical content, and that will include both on my main Combo Class channel, some episodes about the theory behind piano chords and scales, and it'll be shown on piano, but for any type of instruments, chords, and scales, or not any instrument, but any using a typical Western tuning. And later I'll also do ones about guitar, ones about making digital beats, even ones about structuring flows and rhymes in rapping or singing. And these are things that will get main episodes spread out. And while that happens, there will be times where on this channel, warning, once in a while, I may put out a music video on here, because I have a lot of songs that I have made and ones I'm currently making. And there may occasionally be a music video that randomly comes out on this channel. Don't worry if that's not what you like, because you can always just listen to the first minute and decide to move on if you don't like it. But it won't mean the channel is going just to that. But given that this is technically my bonus-ish channel, it is going to be where that form of musical content gets put out. I did a while ago also compile some of the soundtrack beats I created and shared some of the older ones on Patreon. Maybe I'll get those together for all of my viewers at some point, and that would just be a fun upload, maybe, as just like, it would be a pretty long video, but just all the soundtrack beats that I created that I'm recently using. And we have some random notes about clock tariffs. Yeah. Like I said, I shouldn't get political about that, but next time before people vote, please Google more about what tariffs do. Anyway, somebody says music is indeed more important. And for anyone who doesn't care as much about the music, what I think you'll find interesting is there's a lot of math within it. I know my viewers enjoy math. And the way I teach, because I used to be a music teacher, the way I teach things like piano chords and scales, straight up modular arithmetic, literally modular arithmetic. And so that's going to be really fun. There's a few different clocks I could create that I'm going to create for the episodes and just to have in the background that represent music, such as one that represents what's called the circle of fifths, and another one probably that just represents the 12 notes in ascending order that occur in a scale. And between those two, you can show some crazy patterns using modular arithmetic to do things like a lot of piano chords look different. Like all the ones that are called major chords, a lot of them look different, but they all have the exact same modular arithmetic math. And somebody says, isn't music more about 8 than 6? It's true, music loves twos. 6 does occur in music when you use triplets and things like that. Like 2 triplets next to each other is 6. However, for some reason, to the human ear, it sounds really good to divide things in 2-like structures. However, popularized by 3-6 Mafia and then more so by the Migos, the triplet flow in rap is something that works on a lot of beats that has caught on more in years since those artists experimenting with it. And that is something that I will cover someday, that triplets can sound really good in certain things, like a rap flow. And more so, though, music loves halves and quarters and eighths. For some reason, that stuff sounds good to the human ear. And someone says, buy American clocks. I get all my clocks used. So unless there's one that I see that looks really cool and is only like $10 or something, almost all these I get used. And so I don't know their origin, but their current place where I get them from is right out of my neighborhood. I've gotten them from Craigslist and Nextdoor, people giving stuff away. I've gotten them from a lot of yard sales, from mostly sort of like thrift store-ish things. There's a place around here that has like a lot of used furniture and stuff, and I'll go there like every half year to see which new clocks they got. So what clocks I get are the ones that life happens to bring me. So maybe if you believe in weird sorts of destiny, these are the clocks that were meant to be here because they just found their way to this home. And even if you don't agree in destiny, maybe you like the clocks. Anyway, thank you to everyone with random comments and just joining me today. I do think before long I might wrap up, so as we do a few last little topics, let's try a bite of this thing. That's good. You can taste the fractally crunch. Like the fractalness gives it a good texture. It tastes like you have these things you crunch and then smaller things that crunch and smaller things. It's like what you'd make in a lab to have a cool texture. And the flavor is sort of like broccoli or cauliflower-esque, but maybe I'm biased from how it looks, but I want to say it tastes better than broccoli or cauliflower. It tastes really good every time I've had one of them. Like raw, I think eating it raw, this tastes better than broccoli or cauliflower would. That was good. Anyway, thank you to everyone joining me to see Weird Fruits for a little wrap up to our stream about the current state of Ramsey numbers. I partially just wanted to make a little bonus video that was like, hey, check out this new stuff that's been proven about R55, but it was one of the ones that made more sense to do in a live stream form. So hopefully some of you enjoyed that, and do remember to check out, if you haven't yet, at some point on the main Combo Class channel, the episode I've made about Ramsey numbers. I linked that in the description here. So, that one, it was back in grade -2, but it has a more in-depth description about Ramsey numbers, but it doesn't have some of these updates. The chart that I show of what was known about the Ramsey numbers has changed. We've discovered new things and proven new things. Anyway, I think I'm going to wrap up there, but thank you all so much for joining me. I love you, and I'm going to be filming some cool stuff in nature at my friend's cabin the next few days, and so I'm excited to show you some of that when I return on Monday or Tuesday. And until then, maybe I'll put out more bonus stuff before then, but if not, make sure that you are caught up to date with all my main episodes, or some random bonus videos I've put out on this channel recently. And if you're ever bored, pretty much all of my live streams get saved in video form on the live tab, so there's a lot of content if you like watching the live streams. But anyway, thank you all. Thanks for joining me, and special thanks to the people who help support on Patreon and memberships and stuff. And remember, if you want to chat more with Combo Lords, to try the Discord and see what cool combo conversations may be occurring there. Anyway, okay, for the fifth time, thank you, love.